let's continue for another hour, right? Yes. We were speaking about automation versus augmentation and where it started. So let's stay in the history and let's make a few examples, also some back from history, other more recent, about whether is automation or augmentation, which features they have while being automation or augmentation. But before doing that, let's consider this. Do you know? Probably not. Do you know this thing, this essay? This is called "As We May Think" by Vannevar-Bush, or 1945. Okay, no surprise. Vannevar-Bush, no problem. Vannevar-Bush was a U.S. scientist / politician / policymaker, etc. That wrote this essay for The Atlantic, that was a journal, in which he imagined a device, a future device, a system. Again, this is 1945, so 1945, not even a keyboard connected to a computer, just to put this in perspective. 1945, and he was saying, consider a future device in which, well, it's a long essay, it's linked here in that page, but this is one of the main points, in which an individual, so a person, stores all his books, records, communication, and which is mechanized so that it may be consulted with exceeding speed and flexibility. It is an enlarged, intimate supplement to his memory. So, imagining a future device that is able to store things, books, report, material, communication, and it's mechanized so that all these things can be consulted, retrieved incredibly quickly and with a lot of flexibility. And in 2029, they also, some people, this device, Vannevar-Bush called it the Memex in the paper. And so we don't have the audio in the room, but we have subtitle. This was a video made after clearing that from the paper tried to rebuild this device. And this is a general picture similar to many drawing of Vannevar-Bush about this Memex. So again, big desk with a lot of things on it. And for watching and listening,
The owner of the Memex, let us say, is interested in the properties of the bow and arrow. He has dozens of possibly pertinent books and articles in his Memex. First he runs through an encyclopedia.
so he is searching for, just to repeat, he's searching for information about bows and arrows. So by clicking and inserting this information, I want to like to retrieve documents about bows and arrows. He first runs through an encyclopedia.
Interesting but sketchy article and leaves it projected. Next, in a history, he finds another pertinent item and ties the two together.
So he continues to search and he finds another interesting item not in the encyclopedia and ties them together, link them.
Thus he goes, building a trail of many items. Occasionally, he inserts a comment of his own, either linking it into the main trail or joining it by a side trail.
So, and this person could also have another portion of the tool, the device, in which you can have a joint trail where these things can be put together with the notes, and so it's creating a new document, a new artifact, starting from the information in the encyclopedia and the other paper. And notice that it links them together, the content in the encyclopedia with the content from these other reports about arrows.
A particular item. His trails do not fade. Several years later, his talk with a friend turns to the Turkish bow. In fact, he has a trail on it. It is an interesting trail, pertinent to the discussion. So he sets a reproducer in action, photographs the whole trail out, and passes it to his friend for insertion in his own minutes.
So then it takes this research that is conducted with the encyclopedia and others, and, well, doesn't print but create this disk to pass it to the other person. Well, and then there is the details how this could be built for all this mechanical part that are not really important now. But I have two questions for you. Is this a device for augmentation or for automation? First of all, that should be easy. Augmentation. It's clear for augmentation because it's for providing more storage, memory, getting access to other information that one person cannot have all in his mind. And does it look like to be related to a current piece of technology to you? Some ideas? More specifically? No. Yes? Something else? If I say to you that it links two pieces of different documents together, hypertext, the web. So actually, it seems that Berners-Lee, when creating the web, was inspired by this, by the ideas of having documents that can be linked together so that you can move from an encyclopedia to another report just by following a link. So in the video, say that we put together two documents, and it appears something like link document 1 with document 2 or something like that. So this is a link, and it's something that is similar to what we have now with the web. So hyperlink document. So this is not clearly about augmentation automation, but again, in 1945, some ideas were already there of things that we have now, like the web. Another example, do you know this? Any of you have done this? Maybe people working with virtual reality, something like this? No? No idea what this is? Okay. This is a paper, and they made a video for the paper in 1980. So again, not so recent, not old like the MEMEX and the other things, so just something more recent. And the SIGGRAPH conference, that again is one of the SIG that we have said before about ACM, about computer graphics. So they are studying how to interact in virtual reality, augmented reality, and these kind of things. And in this case, this paper was called Put That There, and was a voice and gesture at the graphical user interface. And here show probably how it works. No, not in Dutch. Subtitle.
Create a yellow circle there.
Okay. So I don't know if you listen, but say create a yellow circle there, and point to a specific point in the screen, in front of him, on the wall in front of him.
Create a cyan triangle there.
So you see there is this pointer here, and so he points on a position on the screen and say create a cyan triangle there, and the system created a triangle there. So that's why I put that there, because there is indication of where to put something that will be then created vocally.
Put a magenta square there.
Then put a magenta square there.
Create a blue diamond there.
Create yet another object.
Move that there.
And with same mechanism, does not create things, but also move things. So move that and point to an object on screen there, and point to the final destination. So instead of saying, for instance, for movement, move the yellow circle closer to the triangle, that is just one triangle, so it should be easy to get it. It used the same mechanism, put that there. And the video goes on, and that was a paper. So question for you. Two kind of question about speech recognition. Why do you need to point? Why do you need to talk? What might go wrong? Think about, put that there, speech recognition, because there is speech recognition. Create a triangle of a specific color and put the triangle there. Why do you need to point? Why do you need to talk? And what might be wrong, go wrong in the system? What cannot work well? Why? Think about the system. So why do you think that the authors put together pointing and talking, and not only talking, or not only pointing, or pointing and then using a mouse? So in 1980, we just had mouse, keyboards, joysticks. So you can also do this kind of things. Why pointing and talking? Yes, that could be a good reason. So you point because we typically say, okay, turn on that light, that lamp. So we point and talk to normally. So that could be one replication of what we do as people. But why, for instance, it's a good idea to you or not to use the same mechanism also for moving. So you create this 4 object like in the video before, and then for moving one object close to the other, it used the same mechanism of pointing and talking. Move these, that, there. Instead of saying move the circle closer on the left of the triangle. That, in this picture, there is just one circle and one triangle, so it cannot be made ambiguous.
What if you have many circles? So move the circle there, what is it? So you have to point which one. At that point, you can say move that.
That is true, but I can have a counter argument that is, yes, if you have more circle, there is ambiguity, because which one? But the computer, the system could have asked which one. And I'm going to select the first and the second, and then you certain point say the first, the second, the third.
At that point, you have another interaction in which you have to point.
No, I can speak.
Okay. Do you reduce uncertainty on user goals or on what the user can do?
Yes, to reduce uncertainty for sure. It could be good things, because well, speech recognition is not even now so good that to allow any kind of speech. imagined in 1980. So that is for sure for use uncertainty from the system, and also, as he was saying, to reduce time, because otherwise we'll have a conversation, no? So instead of, okay, point this there, which circle, and then I have to answer with circle, and then the system needs to highlight different circle, and there could be another difference. That is, think about what I told you before about human-computer interaction. It will be easier to just learn the single way of doing everything. You do everything by pointing and talking. Everything you do in this way. You don't have to do this for creating and then for moving, do another thing. You just have to learn create and move. And then all the mechanism for creating and moving is point and say create move. Point this, that. Create that, there. So it's the same mechanism replicated. So simplicity, less things to remember. You just have to remember create a move and how to do this, pointing and saying pointing stuff. So it's more natural. What might go wrong in the system for speech recognition, even today, probably? Could something go wrong in creating and moving stuff?
There could be a misunderstanding recognition of the pointing mechanism could, I don't know.
So yeah, the pointing mechanism could be misaligned. Yeah. So you point on the left and you see the pointer on the right, and so you say, okay, why? Oh yeah, but okay, it's frozen. Yeah. Well, okay, let's avoid that everything is stuck case. But yeah, the pointer could be not very precise, so you can you need to maybe adjust your pointing. And for the speech, you say that. Can you repeat? Misinterpreting. So like instead of creating a yellow circle, it understands create another color circle, and so it creates a circle of another color. If it's not something that you want, you have to point that and say delete it or destroy it or whatever the system will support. And these are things that can go wrong, clearly. They are particularly critical in this case. Yeah, in this system, The system, no. What could be the worst thing that you have to do? In the speech, recreate, delete and recreate, so do one more step. That is not critical, but again, if you are using a system like this for, I don't know, creating all the graphics, let's imagine that it can do better things and not just circle, and you can say create a person or create a dog, and there's a lot of misunderstanding, then you will have waste a lot of time in doing this instead of doing it with a mouse on the keyboard, probably, right? Good. And so, but it's not a high stake. In this case, it's not high risk. It's not high stakes. So errors can happen, but they are solvable. Maybe for the pointer, you just need to move slightly your arm to the right position. For the speech, you have to speak again for better understanding. This was clearly a prototype. Now you see here, this person is in a room when there is nothing else that him and the computer and the speaker recognition. That is probably the things on the left, and there is the screen. So there is no noise, there is no interference, there is no other people. So it's a well-controlled environment to do this kind of thing. If you want to do something like this in a cafe, you probably cannot reach the same kind of capability, of same kind of performance that you can have here in this room. Is this augmentation or automation? It's augmentation. And well, And instead, about people. What can people do wrongly with this system? Again, probably not big, high-stakes things, because it's just creating element on a screen in this case. But what they can do wrong for them? How the system can go wrong for them?
Maybe they can change their mind about the photo while they're saying the comment. So, how do I change my mind? So it's wrong.
Okay, and this kind of thing is not even possible now, or correcting while speaking with a speech recognition system. Yes, that could be, but how the system might fail for people? Can everybody use the system?
Maybe you have a different pitch of voice. The system doesn't understand it.
A different pitch, but probably not that one, but it could be adapted different pitch of voices, all right? Stronger, lower, higher. Not everybody can use it. Blind people, people who are blind, cannot use it. They don't see where they're pointing, right? If you cannot speak, you cannot use it. If you cannot move your arms, you cannot use it. So in a way, it's a multi-modal system, because put together multiple modality together, pointing, speaking, seeing things together. But in this case, for some people, it's not usable. It's not possible to use it at all. So this is something, again, to keep in mind when designing a system. Who is your target population? Who are you building for? And is the system that you are building for usable for your entire population or not? Because I can be blind, so I cannot see, but I can have just a disease in this moment that makes my sight working less, and then I can have an operation and restore my sight, like cataract. Or I can have problem with my voice because I got a cold and my voice, I cannot speak because I cannot emit sound, but it's temporary. Or I can break my arm and I cannot point but it's temporary. So just not only think about extreme cases, but also this could happen for in the daily life, because again, life happens. So this is something it could be considered when you also design a system. Who are the people you are, how the system might fail with respect to the people that is using it, who are excluding from using your system. Okay, so moving a little bit on a quite different topic, just to introduce the next point, the next example is measuring intelligence. How do you measure intelligence in artificial intelligence? And you measure intelligence? Probably not. So actually, there is probably a way to measure intelligence. We are measuring accuracy, we are measuring performance, we are measuring usability, we are measuring robustness, we are measuring precision. We are measuring a lot of other attributes that, in a way, put us saying, okay, this system is sort of fits well with our goal. What we call intelligence in that specific moment. Because we typically, especially in a data-driven AI, we don't think about a general intelligence like replacing the human brains. But just think about, okay, let's do this task better, in some way. So more intelligently in sense of better. One thing that we can do, measure a little bit more precisely, is also the joint performance of a task between a human and an AI. So even if we take the same task and we gave it to a human and an AI, how we can say that the human is more intelligent in doing the task than the AI or vice versa? We can have some metric, but if we change the matrix, we clearly can change the results. So one thing that we can do is just to put together AI and people in a way to augment, but more specifically to have them collaborating. So human and machine working together to achieve something that a human alone cannot do, or cannot do so well, or a machine alone cannot do alone, or not doing so well. And here in the picture there is an example. What do you can imagine what is this? I don't know, maybe not, but well, what is doing here in the chess playing, and why there is a computer? No, it's not, more or less. It's not a human versus AI challenge. It's called Freestyle Chess, and you have two humans playing chess, but they also have computers to help them in choose the next move, in support them choosing the next move, in forecasting what will happen if the other person. So both here you just have one person, but outside of the picture here you see another computer, because here there is another person. And so in this other computer, maybe you don't see it very, very big, there is the representation of a chess board. So there is not augmentation. It's not that the computer is suggesting you should move that, but there is collaboration. So slightly different. The user, the person, can choose at a certain point either to move or to ask for more information, for suggestion, for whatever, and then move. And then move accordingly to what he listened, in this case, or ignore the suggestion. It's more like having a pairs of people there and say, okay, what I need to do now according to you? And the other person say, you should move these. But then the player is ultimately the one that makes a decision to move or not in a certain direction. So like having a pair of players that speak together and decide which is the strategy to move. But instead of having two people, you just have one person and a computer. And this is actually called freestyle chess, and there is tournament. There were, for sure, I don't know if there is still now, but there were tournaments on this until a few years ago. In which here, you don't have augmentation or automation. You have collaboration. That partially is augmentation, because the computer can support the player, but in augmenting the performance. But it also can ignore the suggestion and can also not ask about the suggestion. And there is automation in part, because when the person is asking to the computer is providing an automatic answer with the input that it has, independently from what the person did before, because it just have a look at the dashboard, at what's called well, at the chat, the play at the game that is unfolding, and get decision, get probability, get according to the other, get information according to what the other player did, etc. So here the strike differences between automation and augmentation start to a little bit fall, or just introduce a new element that is collaboration. a couple of peers at the same level that speak in a way, communicate, and collaborate towards a decision. And sometimes the human can say, okay, I will follow the machine. Other times say, I'm not convinced, let me do another simulation, maybe with the machine. And in other case, just don't ask because it's easy what to do next according to his own experience. And here there is also probably a part of learning in which the person is learning from the computer which are the possible moves, so that the next time that the person is playing and there will be a similar situation, he already knows that the solution provided by the computer is more or less reliable for that specific activity, the specific move. And this is quite, it's often present with robots, for instance. So here in picture you have these robots. If you want, there is also video. We can skip the video. But this is the Carnegie Mellon University in Pittsburgh, United States, in which they have these cobots. They call it cobots, these kind of things, that are novel symbiotic autonomy. We found the symbiotics, something of symbiotic in the panel last time, in which the robots are aware of their perceptual, physical, and reasoning limitation and practically ask for help from a human. So there is a collaboration, two entities to reach a certain goal. So if you look in the video in this Coral project, you see, for instance, that this robot can be used to, so you see these robots are not humanoid, doesn't have legs or arms, so just have a screen and speakers, microphone, and a tray in which you can put things on. So you see in the video that, for instance, these robots were used to greet people in the building. So you are in your office, there is a cobot, and you say to the cobot, please go greet this specific person. So this robot go to the elevator, and when it recognizes the person, then it presents itself and greet the person and guide the person to the office or to the meeting room where this person is expected. Or another example that there is in the video is people are doing coffee and wants to bring this coffee to another colleague in another room. And these videos are before COVID. They put the coffee on the robot and the coffee can go to the right person. With the message, this coffee is for you from person A and person B. So it's something, not just some coffee arrives, but some coffee arrives because some people that you know ask me to bring this to you. And the person could say, please go there and say thank you, and the robot will go. So there is a sort of collaboration. And again, also in this case, is automation or augmentation? Who say that this is automation? Okay, who say that this is augmentation? It's a mix of both. Yeah, it's something different. Because it's not actually augmenting human performance, right? Because if I'm sitting here and the robot is going to greet another person, is improving my performance? Yes, probably I don't have to dedicate time to greet the other person, and so I will probably not waste 3 minutes. But it's such a big deal. Or if I want to, again, if you want to offer me a coffee, and it's just movement or going back and bringing the coffee, or if I want a coffee, I can say to this robot, please, can you go taking a coffee for me, and then this will reach the room in which the coffee is, and probably also this in the video, in which the coffee is, and we'll ask somebody, can you do a coffee for this person, because they cannot do a coffee, clear. They don't have hands, they don't have arms to manipulate object. So there is some automation, because the robot is going around alone, and they speak, they listen, they recognize people, and they go in the right room for coffee. They don't go in the elevator for looking for coffee. They go in the where is the coffee machine. So there is some kind of automation. There is some intelligence. There is a recognition of the place of people, etc. But they are not taught. Yeah, they are partially replacing human because they are going to get coffee, but they are more buddies. So other collaborators for which you say, okay, can you please go and take a coffee for me, or go greet this person and greet this specific person, not another random person that is entering the building, just that one. And accompany that person to me and give this message to her. It's a more symbiotic relationship in which the robot is helping the human, and when the robot cannot do something like do a coffee, it's asking a human to do a coffee for it, so that he can bring to the person who originally wants the coffee. So there is some kind of autonomy. And again, it's difficult to say this is clearly automation, this is clearly augmentation, because it could be both or none of these. Then we can have obviously also here some question that is, how do people learn to interact with the robot? There will be surely a learning process for humans especially. So if you are expected to meet with Professor X and you see a robot, what do? Maybe it will be strange for a while, but then you maybe understand, but there is no clear instruction. It's not something that you're used to. So it's the robot that should try to communicate at the best the intention that they have. I'm here to greet you. I'm here to bring you a coffee. It's the same robot, but it needs to communicate better. How do the robot learn? The robot can learn in various ways, supervised learning, unsupervised learning. But how the robot learn about human reactions? Maybe some things cannot be really imagined at the beginning, how a new person reacts to the robot greeting you. Is ignoring the robot, and in this case, what is going the robot do? Following the person, like stalking, or please follow me, or not, or ignore that and go back and say, okay, I was here to greet her, this person ignored me, who cares? Which is how the robot learn which is the best way to do this thing. So these are all challenging things that can happen. And this brings more and more closely to another aspects that who have the control of what happens. Is technology or is human, or both, or together in a symbiotic way. So one thing that we know for sure is this, that people must at least feel in control or their lives and surrounding. Because they feel that they don't have the control, they will stop using the technology almost automatically. So there is still this feeling to have some level of control, what happens around them. And this is something that we can start with as an assumption, a statement. But again, at least the feeling of having control. Maybe they don't have really control, but there is the impression that they have. So to give at least this feeling, we should consider these three things. When we put intelligence in things, people should be comfortable with the action made by the intelligence system, understand, and here we are again, understand why some action are happening, and trust the system. Because if they are not comfortable, like useful, usable, and used, if they don't have, even if they understand and trust, but they're not comfortable, they will probably stop using it at a certain point. And if they're comfortable and trust the system but don't understand what they do, at a certain point, the trust will go less, will go lower, and they will stop using the system. So these are three essential ingredients for an intelligence system relationship with, that has some kind of relationship with the person. The person must be comfortable with the action the things is doing, whatever it is. It could be a smart home, it could be a robot, it could be a car, it could be a software on a computer. Understand what's happening, why some things are happening. And this doesn't mean that every time you need long explanation, everything, but just have maybe sensible feedback when things are not reasonable, obvious why it's happening in this way. And then there is trust. And we clearly, this is in general, should avoid over-exaggerated expectation, like we have reached human parity in speech recognition. No. And this is the pre-assumption. I can speak with it, it can understand a word, thus it has full language understanding. And this is something that we should avoid as designer. Like, okay, this is a speaking machine, so we can speak, we can have a conversation. But it's also something that people that use the system have. Oh, I can speak with this thing, so I behave like another person. That is not true, at least today in speech recognition. These devices can answer specific instruction, maybe complex but specific instruction. They can misunderstand us, etc. So this assumption that we have, we should try to lower it and expect other people that could have this assumption to make clear that yes, you can speak with this, but this is not like a person. So you cannot say everything that you want like you say in a person, to a person. You can say some things in a certain way and receive an answer. So if you have one of the Amazon Echo or Google Home or whatever, you probably know that if you say something in a certain way, you will get an answer. And if you say something in a slightly different way that will be understandable by everybody in the world, they don't give you an answer. Because that is a kind of sentence that is not good for them. It's not understandable. That doesn't match with the weather forecast intention, so it doesn't give you the right answer. If you slightly change the question, that you have the right answer, the answer that you were expecting. But this should be clear, because otherwise people will think, okay, I can speak with this, so I'm speaking. Whatever I want to tell, and they will answer, but it's not the case. Okay, I think that we can skip this for now. But all these things about collaboration, about control and trust, brings us back to human-centered AI, in which we have the AI system that must be reliable, safe, and trustworthy, and the goal of having amplification, augmentation, and enhancing. So in a way, we can have automation and augmentation together. And there is one classical example in all the Schneiderman talk and paper about this topic that came from the real world, from something that all of us has now with us. Do you can think of this example? There's one thing, one software application that we have with us now. I'm pretty sure that is a good example of something that augments us, but also automate something while augmenting us in doing a specific task. Again, remember, interaction is always fulfilling a goal, a need, people doing a specific task or goal, which could be something that is augmenting us performance in doing this task while automating some aspects of it. The smartphone is too big. Is something in a smartphone. It's not really augmenting. It's more annoying, probably. something that probably you all use multiple times per week at least, maybe per day also. That is on the smartphone, but it's also in the smartphone without Siri, etc. Something else. No, not the touch screen. There is not a lot of automation in touch screen. It's more. No. It's software. You use it for making photos. What use for making photos? The camera application. That is, if you think, especially in modern smartphone, a good example of augmentation plus automation. Why it's augmenting your performance and what is automating to you? Think about modern camera application on smartphone. There is the autofocus, but not only. Set automatic exposure and other things. If you are moving, try to stabilize the hand movement a little, at least, reasonable. And all this stuff is done automatically. You have no control. Maybe you can disable it. But for the stabilizer, for instance, you have no control on the stabilizing. It's just stabilizing for you. Setting the exposure. It's something that does to create a better photo for you, to augmenting your performance in making photos. The goal is augmenting, but in augmenting is automating some steps. The stabilizer, exposure, and there are some cameras that maybe take 5 photos and then put them together, pick some part of one photo into the other, or just pick the best one. But you press once, you make a photo, and the phone makes 5 photos, and then pick the best one for you. And you don't even know this, probably. You don't have control on this. It's totally automatic. But the goal of all of this is to make better photos for you. And on the other side, you have full control on the main goal. Which is the main goal when you want to make a photo? Make a photo. So you can decide where to shoot the photo. In landscape, in portrait, inclination, distance, you can enable the flash, you can disable the flash. You can also tweak maybe exposure, etc. if you want, if you know how to do it. You can enable portrait mode, you can enable night mode. That again are also part that automatically do some stuff for you. And you just have the control saying, please, this is night mode. And the camera does things automatically. You don't know what this does. You don't have control at all on that portion of the things. But you decide whether, when, how, for how long, how many photos you are taking in this moment. So you have full control on your goal, that is making a photo, making a good photo. The cell phone, the camera, is augmenting, is enhancing your performance, hopefully, in doing the photo. So if you have a traditional mechanical camera, you will not get, if you're not an expert, a good enough photo. Because you don't have all this kind of control, you don't have stabilizer, you don't have anything of this. If you're an expert, you can probably do very good photos, or even with a traditional, not electronic camera. But if you are a random person, like me, for instance, you can probably obtain better photos with a smartphone than not with a compact camera, traditional style, not one enhanced with technology, even in this case. And do you trust the camera application? Do you have problem with trust, with safety, with the reliability in that process? No. You trust the camera. You see the photos in the end, and they are on your smartphone. And you can share it if you want, but there is nothing You don't question. You care about understanding what exactly it does? Not really, probably. Until it does photos as you expect, and until you can experiment. Okay, I'm doing this photo, I don't like it. Let's change this. Let's enable night mode. Let's disable night mode. There is no explanation, but you can experiment. You can tinkering about things that happen. So you are trying to understand in a way, and this understanding help you inform trust. So that is a very good example of this definition. It's very minimal as an example, but still it's something that tries to put together automation on some part of the process with the goal of augmenting, of helping you to reach your goal, your task. So in this idea of human-centered AI, in which this is an example, the idea is to move away from this dichotomy of automation versus augmentation that we have seen starts from historical perspective and is still present in some places. And to say, well, actually, in some cases at least, we can have both. We can put together both goals. To replace human in something like stabilizer for photos. You can move a little bit if you want, because it's the system that compensates for your movement automatically, and augmenting the final goal of taking a photo. So this is, again, not only human-centered, but also with this perspective, overcoming automation, the dichotomy between automation and augmentation, and more, also overcoming the dichotomy about full control and full computer automation. We have seen this. This is also very typical with, we said before, level of driving, autonomous driving. You have, on one side, human control, and you are driving. And on the opposite side, computer automation. The car is driving alone. And so you have no control, or very little control. Maybe you can say to your car, I would like to go there, and then it moves. Maybe you can say, I would like to take the panoramic road, maybe. And so the path is recalculated. But this is the kind of control you typically have in a fully automated car. If you have full control, you have to care about everything. So this is typical. This is the normal way in which we see things. Actually, there is the level of driving automation that is structured exactly in this way. And the human-centered AI framework say, okay, this is true, but what if we start thinking in 2 dimensions instead of 1? What if we can admit that instead of having full control, human control, or full automation as opposite ends, we can have both? So what Schneiderman is proposing here is saying, okay, for some application, like the camera, we can think of a system that has high level of automation for some parts, at least, of the process, and retain high level of human control. Because you can decide whether how make a photo, how much photo, which parameter to enable, disable, etc. So you have control on your final goal, or your final task. But you also have full automation. So what is proposing this framework is just saying, okay, let's try not to think these just levels, whether you have control, or human, or a system, or a computer. And if you move towards control of the system, you remove control from the human, or vice versa. Let's be more creative on this. And this remains as a theoretical level, unfortunately, because then it's not easy to actually implement. But as a way of thinking, as a perspective, there could be application like the camera in which you can have high automation and high control. And then clearly there will be also application that has low control from a human and low automation, or application that has high automation and low human control, and application that has high human control and low automation. And that still exists. The one dimension is this here between high human control and high automation, so which you reduce, but it adds other two quadrants. Probably the first one is not really interesting. You have low automation and low human control. Not particularly interesting from us. But most importantly, it adds this other quadrant, and in which say, beware. Typically, the things, and then there is a paper, if you want to read the full paper, is linked here. The things that typically have high control and high automation risk to be, sort of by design, the one that are more reliable, safe, and trustworthy. Because you still have full control. You can do everything. But yet, the system is operating in a way that is reliable, safe, and help you to understand, to explore, to think about what you want to do. So this is the next ingredient of this human-centered AI principle. Let's try to put together not only automation and augmentation, but also human control and not human control in solving the same task. So again, the negative aspect of this is that it stops here at this level of theory. Let's say it doesn't go, okay, now how can I apply this on my research? But show you with some example. The paper has a few other examples also of things that you can put in the other quadrants of things that you can possibly do. And it's a starting point. All of these, as I said before, is very, very recent. It's 2020, so it's less than 2 years ago. But it's a way of, it's different perspective. Let me skip this. To give you something a little bit more, slightly more applicable, and then we will have lectures and exercise to have things more applicable that you can check actually, like checklist, I did this or not. There is a slight variation of human-centered AI that add the interactive part in the beginning, and it's also still quite recent, 2020. Again, that still is a little bit of the high-level theoretical part, in which say that interactive human-centered AI is an artificial intelligence that enable interactive exploration and manipulation in real time, and it's designed with a clear purpose of human benefits while being transparent with control over data and algorithm. So this is complementary to the other definition, but adds some more specific ideas. Interactive exploration. Control, not just general control, but control over data and algorithms, transparency, etc. And the main idea behind this is to have something that is observable. Because you can explore, you can observe something. And if you observe how things work, they are more transparent, you understand who has control, and becomes more trustworthy because you understand the things that are happening. It can become more trustworthy. But differently from the other, Schmidt lists 8 properties of this interactive human-centered AI. So something a little bit more closer to what you can do. Still a little bit generic, but he say that an interactive human-centered AI should have at least some of these properties. So people, users, can interact in real time with algorithms, models, and data, because it needs to become more observable. So if I want, I can change, tweak things to better understanding. And the impact of these changes should be reflected, observed in real time. And also I can explore things, like with the camera, but also at the level of specific decisions that are made. And you say it's more important, the property number 4, is more important in some cases to lower down the speed to allow interaction, to allow observability, to allow the user to understand, to build trust about how the things work, if they want, clearly. So it's not mandatory. And a system should also clearly state in some way how humans can benefit, and this is, again, human-centered, so it's imaginable. It should explain which risk the AI poses, who has the control over everything, what data, knowledge, information is created and informed to the AI. This maybe is not in the system, maybe is something that accompanies the system, but it lists a series of properties. And one thing that is crucial here is more related to societal effects that the human-centered AI framework doesn't cover, which is the negative impact of AI technology, of the AI system. Because the positive impacts are easier to imagine, but the negative impact, what might it fail? What can go wrong? Who can use this system in a bad way? So also reflecting on the negative impact on technology that we build. Not just, oh yes, we build a technology, it's neutral, and we don't care, we are not responsible for the use that other people will do. We probably partially are. A few words, really 5 minutes, about understanding. There are really 3 slides. Since the properties speak about understanding, manipulating, etc. And I don't know if you well, this is 2016, so probably maybe not all you. Do you know the history behind HAII, or whatever it's called? Yes, no? Some of you, yes. So in a nutshell, you will retake these slides, not for understanding, for another reason, for risks and features. But HAII was a chatbot trained on WeChat in China. And it works perfectly. So people interacted with the chatbot replied in a very great way, and it seems as smooth interaction between a human and a chatbot that behaved like a human, and HAII learned from each conversation. So more you speak with HAII, the more you get better answer, more realistic answer. What happened, and at a certain point, Microsoft said, let's not put it only on WeChat, let's put it on Twitter. And in less than 1 day, HAII learned to be racist and provide a racist answer. You see here, I fucking hate feminists, and they should all die and burn it in hell. Hitler was right. That is not something that I'm saying, that I'm reading here clearly. A system, the same system that worked perfectly on WeChat, as soon as was made in contact with Twitter, that is clearly an ecosystem very different from WeChat, became a racist asshole in less than 1 day. In less than 1 day, he started to write these things in less than 24 hours. It was incredible. It's an incredible learning process towards the wrong direction. And why this happened? So this clearly is understanding why this happened. So why this happened? This in this case it happened because for the system there were no difference between feminism and flower. So maybe it's fine to say I don't like nature, or agree that flowers are great, but replace flowers or nature with feminism, Hitler, etc., and you find sentences that are grammatically correct but with totally different meaning. So in WeChat probably it were exposed to less problematic conversation than on Twitter. So given that the system doesn't have the knowledge to understand that there were differences, that they're not the same things, nature, flower, Hitler, and feminism, they just put together words in a grammatically correct way. And this created this problem. So it's actually important to understand system, but not only opening the code, because the code of HAII was good. It also worked on WeChat, so not big deal. But also design goals and functionality that the AI system is supposed to support. So understand where you are going to put the system in the context, what it can learn. So for instance, here probably a good idea should have been pre-trained the chatbot to say, well, listen, there are some good words and some words that probably not so good. So if you are just going to use I ate one of these, just skip it. Maybe it's not a good idea. So in some way, so there is in understanding system the user that interacts with data, that interacts also with the model in some cases, implicitly or not. And there is also the visualization, the outcome of all these processes depicted here. So understanding system is complex, is needed in some cases, but in some cases, like HAII stories say, just not enough to open code, read the code. Because if you read the code after the WeChat experiment, you say, it's fine, no problem, it works perfectly. But then you change environment, still textual, still people writing, because in WeChat we still have people writing, so it's not totally different environment, and you have a result that is totally different. And they clearly shut down HAII after that day. Microsoft shut down HAII after the day. And how to enable people to understand the system, what you can do. Well, if you have, especially if you are working with these properties of interactive human-centered AI, so you enable people to also tweak the model to see what happens if you change something in the model, in the algorithm, tweak some parameters, etc. You will for sure need, that could be useful for the users, but also could be useful for you, for the developer, something that allows you to review the output. So visualize a selection of the output sample to say, okay, if I give to HAII the word feminism and flower, which sentences will generate? A few, just to have an idea. Feedback. This is bad, this is good. And we will see how much feedback. Because if an intelligent system is continuing to ask us for feedback, at a certain point, we will find it annoying, and we are going to say, why I need to explain everything, I give continuous feedback. It should be intelligent enough not to ask me every time, did it go right or not? So, but some kind of feedback, implicit or explicit, could be good. Inspection on the quality of the model. And task overview, which is the goal for which you have developed that. The task of HAII was a chatbot to interact with people, but contextualize the task in different scenarios could have helped this. So these are distinct user interface elements, mostly graphical, that can help in understandability, in enhancing understandability. And I was saying before that in a few lectures we are going to, through a process of designing and evaluating human AI interaction system, so we will retake these in a more specific and detailed way so that is more operative and actionable for you to apply in the next system that you probably are going to design and develop. Okay? Any question? Okay, so, well, if you have any question, I can steam here while I'm unplugging everything. We are on time, so have a good lunch, have a good weekend, and we will meet again towards the end of the course, because now we are actually at the half of the course, because we have 7 lectures. This is the 3rd one, so we are half of the course. We will meet at the project presentation at the end of the course, and because the next lecture, Alberto will be here or in room 7S with you to continue this conversation and the discussion. Have a nice weekend.